Okay, after we learned the energy principle, we can use the energy principle to study the instabilities in ideal MHD. Without the convoluted derivation, I will just provide the W in terms of 5 different terms. We know that omega squared can be equals to W over K, and K is kind of, in a way, like a kinetic energy, but without I could C dot, I could C. So K is always greater than 0. So if W is greater than 0, then this will have a real number. Otherwise, it will be a positive, negative, imaginary number. So when omega is positive, then it's stable. Sorry, if W is positive, then it's stable. Otherwise, it's unstable. So in other words, the term, if any term is positive, it's stabilizing, and if any term is negative, then it's destabilizing. So those 3 terms are stabilizing, since it's always positive, and those 2 terms are depending on the sign of it. So it could be destabilizing. So the first term can be understood as the shear Fein wave. You can think the some energy is stored in the motion of in the magnetic field, like an oscillation of the magnetic field. So, and the second term can be understood as magnetosonic wave or compressional Fein wave. The magnetic field, the compression of magnetic field stores some energy in it. So the energy is stored in the magnetic field as well. Sound wave is, this term can be understood as a sound wave. So some energy is stored in the pressure field. Those 2 terms can induce instabilities. So this term, the pressure gradient is a driven term of this instabilities, possible instability. One of the example of it is the sausage instability. If you look at it, if the grad P and grad P and chi kappa is a magnetic curvature. Grad P dot kappa is positive, then this whole term is negative, then it's become destabilizing. So it's unstable. So from here we know that then it could be a bad curvature. We're in a bad curvature region. And on the other hand, the kappa dot grad P is less or equal to 0, then this term will become positive. It will be stabilizing, which is in good curvature. If we put into the aspect of torus, then if the magnetic field is going along the inside of the donut, then the curvature is of course going this way, and let's say the core have a strong, like the inside have higher pressure than outside, then the outboard or the outside of this side, outside will be considered as a bad curvature, and the inside or inboard will be considered a good curvature. And the 5th term, the driven term, as you can see, is a current. So it also can be it's called current-driven instability. One of the example is a kink instability.